On this episode of Oppenheimer Science Mission Legacy, we will explore Oppenheimer's mission while director at Los Alamos. Oppenheimer's story is of significant challenges, outstanding accomplishment, and helping end a terrible war. We hope to share with you a new perspective on Oppenheimer and make the connection between his mission during the Manhattan Project and our mission today.
Was he a hero? Yes, I think he deserves that title. But like all heroes throughout history, he was a flawed hero.
You had the drive of wartime urgency. The laboratory under his leadership responded to that.
They came to a design. It was pretty novel and pretty innovative. And because they weren't actually sure it was going to work, they needed to do a test.
And when he's in the bunker at Trinity, he's clinging to a post, shaking, because it's all come down to this moment. It succeeded, but it cost him.
Fat Man, Little Boy, they were not weapons of deterrence. They were weapons to end a great conflict.
By the early 1940s, World War II had become a deadly global war with no end in sight. And on this mesa, in 1943, Oppenheimer's team began their work. The task was monumental, and the race for an atomic bomb intensified. The initial approach taken by the scientists was to use a gun-type assembly, which involves firing a subcritical mass of material at another subcritical mass using explosives. This was going to be a new weapon, and the scientists working at Los Alamos had to develop innovative solutions.
Originally, they really thought they could use one method of assembly, the gun-assembled method, right, for two different weapons, one using uranium, fissile uranium, and one using fissile plutonium.
It wasn't clear there was going to be enough uranium for an atomic bomb. But there was also plutonium, which in effect was a much better bomb material. But it turns out that plutonium could not at that time be made pure enough to prevent a premature explosion.
In conjunction with the research on the gun-assembled method, they were already starting a little bit of implosion research.
In mid-1944, there was a crisis. The scientists realized that plutonium was not suitable for a gun-type nuclear weapon. Oppenheimer's leadership is about to be put to the test.
The crisis of '44 was a significant challenge. They not only had to develop a completely different weapon design, right, the implosion method, but they had other problems. It was a really complicated design.
And so Oppenheimer had to decide, what am I going to do? I've got a uranium shortage, and I've got a method of shooting plutonium that's not going to work. What do I do? But Oppenheimer had the courage to say, you know, we're going to stop, recalibrate, and move forward along a different line. But he kept both lines of research going, and so ultimately we have both a gun gadget, Little Boy, and an implosion weapon, Fat Man.
This laboratory lives in the shadow of Oppenheimer's ghost. He encouraged that you had to always be open to debate. You had to challenge things when you didn't think it was right. You had to go find the truth from nature through experiments, through theory, through debate. That important feature that Oppenheimer left this lab of, find the truth.
Certainly the academic approach to science that Oppenheimer brought on behalf of the University of California is both formally and informally part of our culture. We're relatively more science-centric than a number of our peer national labs. And we take on big challenges. We took on a big challenge in the Manhattan Project, but we're still taking on big challenges today. We're solving the world's hardest, biggest problems that nobody else can do. So it's another example of attributes of the Manhattan Project culture created by Oppenheimer that still persist in today's Los Alamos National Laboratory.
One of the things that struck me is that he would have regular meetings, I think they were weekly meetings, with his grad students. So he hadn't managed much, but he, you know, like all professors, he'd had a few grad students. And what I see in that record, the skill to ask questions that were just the questions that were needed to be able to help the students move their research forward. It looks to me like his ability to ask questions was central to his management style. And it appears that he had the ability to ask the questions that would move the research forward.
As a leader, he was also remarkably insightful in terms of how he led this laboratory, how he dealt with a collection of vibrant personalities, and how he managed to weld them into a cohesive team and direct a complicated set of interlocking efforts to a very pragmatic and practical solution in an intensely short period of time.
Best example of where what began here ended up in another great American success, and that's the moon effort. Started here, put 2 men on the moon in 1969. That is one of Oppenheimer's greatest legacies. It's also one of the Los Alamos Laboratory's greatest legacies.
To this day, Los Alamos National Laboratory remains at the forefront of national security science.
Los Alamos and the Manhattan Project had a very singular focus, building a bomb to end the war. But that nuclear security mission, which was trying to translate what at the time was actually very recent scientific discoveries into a new capability in service of national security, in a way, that's what we do today. Translating those very recent innovative scientific discoveries in something that can meaningfully contribute to national priorities.
LANL's an amazing place where an awful lot of knowledge and varieties of expertise come together. There's just everything here in order to understand nuclear. This lab is still very important for national security.
Solving complex problems takes a large breadth of skills. People that come from different backgrounds, educations, that work together to answer the questions for a specific problem. As time goes by, our simulations become more complex that bring us from the Manhattan Project, where the predictions were one-dimensional predictions and simulations, to nowadays, where we can do three-dimensional simulations, leveraging the increase of the computational powers that we have access to.
The people of the laboratories are very much aware of the ethical complexity of what they do. At the end of the day, if it were possible to somehow uninvent them, we would probably all stand up and cheer. But it's not. Freeman Dyson may have captured this as well as anybody by saying that we have to learn to live with these systems responsibly and quietly, possibly for a very long time. I think that's sort of the ethical problem we face. How do we live with them responsibly and quietly?
Oppenheimer changed the focus of the laboratory to develop an imploding weapon. However, the scientists also had to design fire sets, detonators, detonating circuits, and an endless number of additional parts. Again, these changes were informed by theoretical considerations and required precision engineering and intense experimentation to validate.
So the implosion method was a lot more complicated than the gun method, and they had to develop new technologies. They had to essentially create a sphere of high explosive lenses that, when they were simultaneously detonated, would direct an inward blast of energy to compress a subcritical mass of plutonium. All of this had to be done very quickly, had to be done with perfect symmetry. And all of these little pieces that had to come together had to be developed.
The fundamental ideas were pretty well worked out in the physics, but a lot of the complexity lay in the engineering. And if you think about it, that was not Oppenheimer's long suit. But still, he managed to create an environment where both the physicists and the engineers and physicists playing engineers could all figure out those problems. I would say one of his geniuses, again, was how do you point people in the right direction, that you can solve problems quickly and do what needs to be done and then get the results.
I had the chance to talk with Kai Bird, co-author of American Prometheus, the Pulitzer Prize-winning biography of J. Robert Oppenheimer.
Oppenheimer would walk into a meeting And he would stand at the back of the room, not at the front. And he would just listen, smoking his pipe or taking a drag on a cigarette. And he would let all the scientists argue about the way forward. And, you know, these are men with large egos. But Oppenheimer had the ability to let them argue, and then he would intervene at exactly the right moment and summarize what everyone was saying and sort of point the way forward, the next step, to explore experimentally what should be done. And everyone would nod their head and say, okay, that's it. And he also managed to convey, I think, his sense of excitement about what was being done here, the importance. And so again, he had an enormous sort of patience and understanding about human psychology that I think made him a good leader.
Oppenheimer successfully managed many moving parts, all running together simultaneously under great scrutiny and pressure while fulfilling his mission.
I often think what it must have been like to have been Oppenheimer in those early days and months, you know, following him, cars following when he drove somewhere. I'm sitting in the house that he lived in. There was a fence around here. There were security guards around his house every single day. The telephone was bugged. Everybody was watching him all the time. Reports were coming to Groves. They were going to Hoover. The FBI was in on it. But the man himself, it must have come for him that balance, you know, the thrill of the work, the promise of delivering something that would save the world with this personal cost. That balance must have shifted every single day. And there must have been moments when he would have wondered, you know, is this worth it all?
One of the things I find really interesting is that Oppenheimer was under constant surveillance during the war by Army security forces. But in focusing on Oppenheimer as a security threat or a potential security threat, people like David Greenglass, Ted Hall, and even Klaus Fuchs were ignored. And so they had free reign of Los Alamos. Nobody was watching them, the real spies, but were focused on Oppenheimer, who was not a spy. You become so focused on one individual as a problem that you miss what's going on around him. And that was certainly true here at Los Alamos.
You think about it, July 16th, Trinity is successfully detonated. August 6th, Little Boy is detonated over Hiroshima. August 9th, Fat Man is detonated over Nagasaki. They didn't just successfully test Trinity and then go, oh, how are we gonna get it over there? What kind of airplane should we use? Is it gonna fit in like a combat unit? How is that gonna drop? Can we detonate it from the aircraft? Do we have to use something else to do that? What are our fail-safes? How many people do we need over in the Pacific to even assemble like the lens systems, right? So all of this logistics, the logistics for delivery, is actually called Project Alberta. And this has been going on in parallel with all of this work that's being done in Los Alamos by Los Alamos people, supervised by Oppenheimer. The other thing that Oppenheimer was managing was the supply side of the whole project. So not just the delivery to the Pacific or the test of Trinity, right, and the final design work, but how do we get all these supplies here that we need? And it was a huge challenge.
One of the laboratory's most significant accomplishments was developing and testing the world's first nuclear device. On July 16, 1945, a prototype implosion assembly was successfully detonated in what is known as the Trinity test.
Everyone who's contributed a little piece of technology to the Fat Man design, to the Trinity gadget, is sitting down there hoping that their contribution is going to work. So tensions were high. This is the proof test, right? That the Fat Man, which is already, planned for delivery, this is the proof test to reassure everyone that these weapons, that the implosion method is really going to work.
He is down at Trinity. He's watching it being assembled on a Friday afternoon. He's just recovered from a case of the chicken pox. He's down to 105 or 110 pounds, and he never was a fat man. He's smoking continually, and when he's in the bunker at Trinity, he's clinging to a post, shaking, because it's all come down to this moment. It succeeded, but it cost him. And I don't think that in the subsequent years, however much he enjoyed them and the fame and the notoriety, I think there was always that. Like he was, standing on the podium with people applauding, but taped to his leg was this ball of emotional cost.
It's truly remarkable how much scientific progress was made during the Manhattan Project. From a fairly basic understanding of nuclear fission, just in a couple years' time, that understanding allowed devices like Trinity to be not only designed, but engineered and produced, and led to the end of World War II. Back then, they kind of lived in a pretty dirt-filled town, and they had the total quantity of the laboratory's plutonium, which was measured in milligrams. And so the fact that they could make the progress they made with such a limited understanding and a limited set of tools is really quite remarkable.
Even today, these early weapons tests give our scientists and engineers great insight into nuclear phenomena.
There's still learning that we can do today with our new weapons designer, our new scientists. There's still learning available for them if they go and they study the Trinity test. There are important lessons in how to approach scientific problems when you're dealing with unknown unknowns that are still learnable from Trinity. We can see how other very great minds attacked that problem, and it's a useful way for us to create our own thought processes.
And so although we've not done an integrated nuclear test in more than 30 years, the data we've gathered from each of those tests dating back to Trinity give us results that our best models, our best predictions have to validate. So there's an important balance of taking new, smaller scale data, combining those with the best models, and then using those models to explain previously acquired data, each of the 1,000 tests we did. If we could predictively explain all the nuclear tests we've ever done, including Trinity, we'd be in a very good space for understanding how the full suite of our nuclear weapons work. There is still important work to do on those frontiers today.
On August 6, 1945, a B-29 bomber named Enola Gay took off from Tinian Island carrying an atomic bomb codenamed Little Boy. This bomb was dropped on Hiroshima, Japan. 2 days later, the Soviet Union entered the war against Japan, and only hours after that declaration of war, Nagasaki, Japan was attacked. The second weapon, an imploding weapon, was codenamed Fat Man. The nuclear bombs developed by Los Alamos during World War II played a vital role in bringing Japan to the surrender table. American science helped bring World War II to an abrupt and victorious conclusion.
So to prepare for the deliverable weapons, they were already working with the B-29 crews, modifying the bomb bays and practicing airdrops. So this is going on in 1944. Even before the crisis of 44, they are preparing for the delivery of the weapons. The military, in its logistical organizational genius, had to plan for all eventualities. What happens if one of the aircraft carrying the high explosive sphere, right, in a mocked up combat unit? What happens if it gets shot down? What happens if a ship that's carrying, Little Boy parts gets captured, right? So they had multiple ways of delivering all this equipment to the Pacific. Tinian, they had been developing that as a base very early on in the project. For redundancy purposes, they sent 3 good sets of the high explosive lenses, Fat Man 31, 32, and 33. So Little Boy also had a lot of redundant parts and combat unit casings sent to the Pacific.
My feeling about Oppenheimer during the war years is that he was acutely aware of his responsibility, both as an organizer and an administrator, also as a scientist, and also as somebody who had to help with the war effort. I don't think he felt he had a debt to the nation, but he had a responsibility to the nation. But he had to take on all these responsibilities that were going to have far-reaching ramifications, and he had to bear those almost alone and make this laboratory successful, and he did so.
So almost everything that Oppenheimer's team was taking on at a certain level continues today. What's different from then to today is the charge of what the weapon is for. So if you go back to World War II, Fat Man, Little Boy, they were not weapons of deterrence. They were weapons to end a great conflict. They were there to fight a battle. And they were fighting a battle in which the way you won wars just materially deplete your opponent. And that has evolved now to where our real principal role is to have deterrence, to try to prevent a great war. One thing that is the same that frequently gets lost in that deterrence discussion is that if you don't think of it as I can prosecute the exchange, whether it's a mad exchange or first or second strike, if you don't think through how you would prosecute and what the effects are, you also don't have a deterrent. And so in the same sense of a war-winning bomb that they had in the Manhattan Projects, ours still have to be, I don't know if anyone wins, at least war ending. But the purpose of the war ending is to try to get this deterrence and stability in the world.
The success of the Manhattan Project did change the course of history. It changed war. It changed the way countries deal with conflict. One of the really interesting sort of studies that's been cited, about 15% of the population was killed due to armed conflict, either directly killed in conflict or dying as a result of disease or famine that might have been a byproduct of conflict. After the use of nuclear weapons to end the Second World War, that number was cut in half. And basically, since 1945 until today, there hasn't been an elimination of war. But what you have not seen is the kind of all-out total war, what we came to call world wars in the 20th century. And the reason is because the consequences are unthinkable. And it's why deterrence works.
J. Robert Oppenheimer has primarily been remembered for pioneering contributions to developing an atomic weapon. His incredible leadership during the Manhattan Project has left a lasting legacy.
The goal of the Manhattan Project was to take these theoretical concepts from the blackboard, right, that the theoretical physicists had come up with, and then translate that into a deliverable weapon in a bomb bay. So I like to say from blackboard to bomb bay. That is the accomplishment of the Manhattan Project. And that's part of Oppenheimer's legacy, and it's part of the legacy of Los Alamos.
There is so much to be excited about working at this laboratory right now. You have to maintain a high level of quality, a high level of understanding. One thing that's certain today, and it's as certain as it was in the Manhattan Project, if our weapons are called on to work, they will.
Too many people, I think, who don't understand the science have tried to either romanticize Oppenheimer or pillory him. There doesn't seem to be enough recognition, I think, of what he was as a scientist, as a leader, as an administrator. We see him in terms of good or bad, unfortunately, I think, in some cases. He was a scientist doing a job that the country asked him to do. I mean, I think that gets missed a lot of times. You know, people talk about what he did, but they put moral terms on it too often, I think. And so it's good to look at him in a little different light, to say he was neither good nor bad, but changed the world.
Did Oppenheimer change the world?
Oh, absolutely. You know, he ushered in the atomic age that we are living with, that has changed our world, that is, the physics that he was associated with as a young man has revolutionized our world, our iPhones, our communications, the artificial intelligence that we're all living with today is something that he was part of in a revolution in the 1920s and 30s. He changed the world, but he also gave us these weapons of mass destruction that may someday end the world. And he was painfully aware of that sort of dilemma and contradiction, and spent much of his life trying to think and talk and warn us about the consequences of science.
Got it now. This time, Rob, the stakes are pretty high. It's going to work all right, Robert.
Some things you can't, are too complex to understand any other way than a story. And Robert Oppenheimer's story is just so mixed up in history. We can all say, what would we have done if we were in that position? People today ask, he should have stopped the bomb from being dropped. But if you consume the story today, we can all understand that being in a position of war, having to do what you have to do during a war, feeling the duty to help contain the output of that and, put the world on a path where we didn't destroy himself, he felt responsibility for that. And I think we all have some level of responsibility. He was famously, channeled that and really felt that deeply. And I think because of the complexity of that whole set of historical facts and that he was central to it, we're still talking about him.
The challenges of deterrence in the 21st century are, if anything, much harder than what we faced at the beginning of the nuclear era, at the beginning of the Cold War. To solve problems that are, if anything, more complicated than anything we've done in the past. And so, if anything, the preservation of Oppenheimer's legacy for that future, whatever it is, I suspect is as important as any point in our history, and probably more complex than it's been, at least for a very long time.
At Los Alamos, we continue to inspire the next generation of scientists. We all want the world to be a better place. If you are a young person considering science, I would like to tell you, read about Oppenheimer, what he did, and what he encouraged his students to do. Be curious, question what you learn, try to go beyond what the textbooks are telling you, and apply your knowledge for good, so we can all together make the world a better place.
Using nuclear weapons helped end the most terrible war in human history. But they also introduced a new era, an era with great promise and a lot of uncertainty. Next time on Oppenheimer, Science, Mission, Legacy, we look at his lasting influences on science and the continued interest in his life story even today.